Hi guys, so we're going to go ahead and continue some of these lessons from the Blizzard packet you guys were given. Last time we did reflections on a coordinate grid. This time we're going over slides and transformations. And what I recommend for you guys is that if you have these notes available to you at home and you're just seeing this video now, go ahead and pull out the sheet notes that we printed out for you on the Google Classrooms so that you can have these on your person and use them to follow along during this video. So, slides and transformations. We have a couple vocab terms. Transformation is not like Transformers, robots in disguise. Nope, not quite that. But it is the movement of a geometric figure from one location to another. So that could be any of the following: reflection, translation, rotation. But today, we're also just going to focus on one of those topics since we already did reflection, which is translation. So while reflection is, say, flip-flopping over a line of reflection, kind of like how you flip over the pages of a book, translation is a transformation in which a geometric figure slides from one location to another without affecting its size or shape. So, you know how in some puzzles, the slide puzzles where you take an object and then you slide it across the table to another location? That's translation, basically, in its physical sense. So that's what we're going to be doing. We're going to be taking objects, such as points or shapes, and we're moving them from one location to another. So, let's take a look here. Here's some directions, such as also can be a reminder for our coordinates activity that we did second quarter. So here's step one. If you are changing left or right, that is a change in the position on the x-axis. So let's say like we have a point on an axis. You know what? Hold on. I'm actually going to draw this out because I know a lot of my students here are visual learners. And I know that my drawing is not necessarily the best. Nevaeh will point that out ahead of anyone. So here's a point. If we are changing anywhere left or right, then that is a change in the x-axis position. However, if we change anywhere up or down, that is a change in the y-axis position. So left, right is x-axis. Up, down is y-axis. Just a little reminder there. So if you're changing left or right, that's a change in the position on the x-axis. And if you are changing up or down, that is a change in the position along the y-axis. So let's say we're starting here at point A, and the coordinates for that would be -3, 5. So I'm going to pencil that in right there for you. -3, 5. So we want to know how we change from point A to A prime. That's going to be our new location. We're taking A and we're moving it over to this location. So let's start with our way of how we calculate slope, which is rise over run. Remember that? Rise over run. So in order to get from here, we have to change its y-axis position first. So if we measure here, we go 1, 2, 3 units down from our starting position, and then we're right in line horizontally with our destination. So that's 3 units down. We're not going to do the rise over run like the fraction format. We're just going to write it out. 3 units down, and then we're going to count how many cross. 1, 2, 3, 4, 5, 6, 7. 7 to the right. So instead of writing it down in fraction, we're going to write it down in sentence. To get from our starting point to our new point, we go 3 units down and then 7 units right. That's one of the ways we will write our answer for transformations. So give me 1 sec and we'll continue this once I turn the page. Just trim my nails. Okay. All right. So yes, you can write this out on a coordinate grid, for instance, and then just write it out. However, there is a translation formula you guys can follow, and this is available to you in your notes. So your starting point, which is illustrated in this formula as P, is going to be X and Y. You know how this works. X represents the coordinate horizontally, and Y represents the coordinate vertically. Remember your coordinate grid activity where we had the giant coordinate grid on the floor and we had to walk the destination. Remember? We started at 0, 0. Then the X coordinate tells how many steps we go, either left or right. Negative means left, positive means right. Then once we arrive there, we go to our Y coordinate, which tells us where we go up or down. If the Y number is positive, we go up. Negative Y number means we go down. So in this instance, it would be a positive number because we go up. So just an example of a reminder about how we graph those points. So we start with that point. Then, in order to calculate the translation destination point, which is pretty much the coordinates of our final destination, we have to take the X coordinate and add how many changes we had horizontally, and then to the Y coordinate, we add what was the change vertically. So if we go right, we add a positive number. If we go up on the y-axis, we add a positive. And the opposite, if we go left on the y-axis, we are basically subtracting or adding a negative number. And if we go down on the y-axis, we have to add a negative number or subtract down. So just remember, positive numbers go right for x-axis and then up for the y-axis. And a negative number means that they go left on the y-axis or go down on the y-axis. So let's look at an example of how we do that. Here's our starting point, P, which is 1, 3, 1 horizontal, 3 vertical, and then we have to get it to this point here, which if we mapped it out, we go 2 down and then 3 right. And then we arrive here at P prime, which is now 4, 1. But how are we sure of this? If we weren't allowed a coordinate grid activity, how could we verify this? Well, we're going to use our formula right here. So here's our point, which was 1, 3, and then we're setting up to find P prime, which is we take the original coordinates and then we combine it with the directions here. We have 2 down. So it's a change in the y-axis. So because we went down, it is -2 or subtract 2. Here, 3 right, it's a change in the x-axis. And we are going right, so that is a positive. So we are going to add 3 to our original points. So 1, 3, and then we're going to do 1 plus 3 for the change in x, and then 3 minus 2 for the change in the y-axis. Do the math. 1 plus 3 is 4, and then 3 minus 2 is 1. And don't forget that little comma to separate them. And just like that, this formula proves that this formula can show us our destination from 1, 3, given the given directions, will land us at our new point, which is 4, 1. All right, so there is another worksheet that we gave you with this. Follows the same formula, but you guys can print out your own coordinate grid or maybe make yours like I did. I'm sure that some of you guys have better penmanship than I do. So you can map it out if you feel like it, or you can just follow the formula here. Either way works, whichever one is your best preference to do this topic. All right, so I'm gonna go ahead and get some water because it's really hot out here, and then I will set up for our next set of notes for video. See you guys soon. Bye.